Hello everybody, welcome back. Today we're going to be looking at 6.7. This is not in your textbook. These are some additional sections that we're going to do. We're going to look at determining the distance between 2 points on a Cartesian plane. So if you have 2 points on a line segment, the end point, the 2 endpoints obviously, and you're asked to calculate this, we have a formula, and the formula is here. The examples, the distance formula given is PQ. We're going to use FG, obviously, because our 2 points are FG. Okay? So, what we can do is label the points. So, like I said, I usually take the points that are to the farthest right as y, x2, y2, and the points to the farthest left as x1, y1. Okay? So, we'll fill in our points. So, the second x value is negative 3. Subtract a negative 2. And then we have negative 1, subtract 1. Okay? We'll simplify that. Negative 3 subtract a negative 2 is actually going to be negative 3 plus 2. Okay? Negative 3 plus 2. Negative 1 subtract 1 would be negative 2. Continue to simplify. So negative 3 plus 1 would actually be negative 1 squared. And then negative 2 squared. You can do that now if you want, or later. So that would give you 1. And that would give you 4. So the answer is e square root 5. And then again, we can leave that as I'm okay with leaving that as a radical, but if you want to go to your calculator and calculate that, you can put in the square root of 5. And when you put the square root of 5 in, you get 2.236, 0.6, 7, and so on. And if it said rounded to, let's say place 1 after the decimal, it didn't say. And there's no units, so then we would fix the units in as well. I'll go 1 place after the decimal if it doesn't tell me, so it's approximately 2.2. Okay? Not equal to, but approximately equal to. That's fine, we just said equal to the symbol, it's not there, that's it. And that's how you get your distance from F to G. So to check your understanding, you guys can work on that. The answer there is 6.3. Let's look at using the distance formula to determine the length of a line segment again. So just another example. This time they don't give you the coordinates. So you want to identify the coordinates first. That would be my first step here. It would be to identify the coordinates that we have. So we have S, and that is at negative 3, negative 3. Negative 3, negative 3. That's bold. I'm going to fix that. There we go. So S is at negative 3, negative 3. That could be x1, y1, and then we have T, which is at 4 and negative 1. 4 and negative 1. Okay? And like I said, underneath you want to write x1, y1, x2, y2. It's up to you. I usually do these would be x2, y2, and x1, y1. Okay? So I got my formula from the previous question. And remember that one's called FG. So obviously this one's called the line segment ST. Alright, plug in our values. So the first x value is 4 minus a negative 3. And then we have negative 1 minus a negative 3. Okay? And we'll clean it up. So we got 4 plus 3. And then we got 1 plus 3. And then we take 4 plus 3, we get 7. And we take negative 1 plus 3, we get 2. And then we square 7, we get 49. We square 4, we get 3. Oh, sorry, 4. We square 2, we get 4. And the answer is square root 53, don't mind me. Square root 53. And again, we can write that in as a decimal. I get 7 decimal. So we just go to our calculators, put in the square root of 53. 53 square root, and we get 7 decimal 280. Oh, 20 in there. 7 decimal 280 109, and so on. And again, if it doesn't say to round, I usually go one place after the decimal. So that would make the 8 round the 2 up to a 3, so it's approximately 7 decimal 3. There's no units, so that's fine. You can leave that out. Okay? Just check your understanding goes with that. The answer is 8 decimal 5. You can calculate that. All right? And then the last one is 6 decimal 3, and you can calculate that as well. So now we're going to do a problem involving a line segment. So determine whether the triangle UVW is isosceles. I think you can clearly tell that the distances from W and V and U to V, they would be the ones you'd be looking for. But what you would do is you would calculate all 3. And once you've calculated all 3, as long as we know the definition of an isosceles triangle is whether you have 2 sides that are equal. So you would just see that the sides are equal, and as simple as that. So I'm going to grab that formula for us that we used for distance. Okay. So we're going to calculate that. So the first thing we'll do is we'll use WU. All right. Okay. And WU, U would have a x value of 1. So it's 1 minus negative 3. Excuse me. And then our y value is 6, so it'll be 6 minus 4. So 1 minus negative 3 is actually 1 plus 3. That would be 2. So we have 4 squared plus 2 squared. So that would be 16. Oh, 16 plus 4. 16 plus 4. So that would give you the square root of 20. And again, you can just leave it as square root of 20. There's no need to change it to a decimal. Alright? Do the exact same thing with, like you said, you can do this 3 times. And if 2 of the 3 give you the, if 2 of the 3 are equal, then you know it's isosceles, right? So we'll do UV this time. I'll use, like I said, I use the point farthest to the right as my x2, y2. It's just, then it's consistent. It doesn't make a difference, but that's what I do. So the first x2 on the V would be, what's the x? So 2 minus a negative 3. Negative 3. And your y value is negative 1 minus, oh, we're doing u, sorry, I did w there, my bad. That would be 1. I do apologize, and I don't need the brackets, obviously, so it's just 2 subtract 1. My apologies. And negative 1 subtract 6. So some of you are probably looking at it and saying, oh, this looks like Pythagorean theorem. Essentially, that's exactly what you're doing, and you're taking the square root. So the formula is just it's exactly what you thought. It's the Pythagorean theorem, and it's switched to just taking the square root of both sides already. So essentially, that's all you're doing. So you've really done this in the past. Okay? All right. And then we get 1 squared is 1. Negative 7 squared is 49. So UV is 50, square root of 50, and you can leave that as square root of 50. So now what we'll do is we'll look at the distance of the line segment of the side WV. We'll calculate that and we'll see if it's equal to the square root of 50. So we'll plug that in. So we have x2 is 2, x1 with the W point is -3, and then we have -1 and -4. So I'm going to copy that. And so that's going to be 2 plus 3, and that's going to be -1 minus 4. So we get 2 plus 3 is 5, and -5 squared. So you can see where we're heading here. 5 squared is obviously 25. -5 squared is also 25 for a final answer of square root 50. So we can answer this question since side UV is equal to WV and WU is not equal to sides UV and VW or WV. This is, or you can say triangle if you want, so I can just go up and copy that. So you can say the triangle is an isosceles triangle. Okay, and that's it. That's all you need to do. Okay, so if 2 are and 1 isn't, it's isosceles. If they all were the same side length, they were all square root of 50 or whatever square root of 20, then it would be obviously equilateral, and if they're all different, then it would be scaling. Okay, so to check your understanding goes with that question as well. All right, you can try that. The answers are there. So it's obviously not because all of them are different. It's square root of 26, square root of 29, and you get the square root of 25, which is 5. So it looks like it, equilateral, but it isn't. Or isosceles in this case. It's actually scaling. Okay. There are some practice questions. There's no textbook questions here, so there's 3 questions that you can work on for practice questions for 6.7, and then here are your answers for those questions as well. Okay, and you do have them on your sheets. All right. So in the next video, we're going to look at the midpoint of a line segment as well. Thank you everybody for watching, and we'll see you again soon in the next video for 3.8.